Hey guys, this is the last of the 3 videos on the factoring method. And in this video, you will learn how to apply the factoring method to solve real-world problems. So if you've been asking, what is the point? Here it is. Remember that when we're solving a quadratic equation, we are looking for the x-intercepts of the function. Okay? So here's example 1. You want to make a vegetable garden. You have enough space in your yard to fit a rectangle with an area of 45 square yards. What are the dimensions of your garden? So, we've done problems kind of like this before, but we were given perimeter and only asked to find the formula for area. Now we're given area. So let's review. The area of a rectangle is length times width. Now, in this problem, we're actually looking for the length and the width. We know that our area is 45 yards squared. We know that our length is x plus 5. And then we need to multiply that by our width, which is 2x minus 3. So I want to solve this for x. So before I can move the 45 over, I need to multiply out that x plus 5 and 2x minus 3 so that I can get my quadratic in standard form. So I have 45 equals x times 2x, which is 2x squared. X times negative 3, negative 3x. 5 times 2x makes 10x, and 5 times negative 3 makes negative 15. So I'm going to clean this up a little bit. I know that negative 3x plus 10x makes positive 7x. I bring down my minus 15, and I bring down my 2x squared. And I set it equal to 45. So now I want to solve this by factoring. If we can factor, factoring is the most efficient way to solve a quadratic. So let's see what we can do. I know that my first step, once I have an almost standard form quadratic, is to move everything to one side. So I've got 0 equals 2x squared plus 7x minus 60. And I look to see if I have a greatest common factor, and I don't. So, I need to multiply a and c. Because I'm looking for two numbers that will multiply to make negative 120, but then also add to make positive 7. So now I start trying to figure that out. I'm going to use my calculator. I know that negative 120 and 1 are too far apart to give me 7. The two numbers have to end up being kind of close together. If I divide negative 120 by 2, hold on a second. The calculator does not want to work. All right, I'm going to have to do it by hand. You guys should follow along with the calculator. If I divide negative 120 by 2, I'm still going to have two numbers that are too far apart. Negative 120 divided by 2 is negative 60. We already figured that out. If I try 3, I'm still too far away. So I'm going to try something a little bigger. What if I try to divide negative 120 by 6? Negative 120 divided by 6 is negative 20. But 20 and 6 are going to combine to make 14. So that's not going to work for me either. What if I try 12? If I divide negative 120 by 12, then I get negative 10. So that makes a difference of 2. So I'm getting a little warmer, but now I've gone too far in the other direction. So let me see if I can divide negative 120 by 8. That's going to give me negative 1 and 5, so negative 15. 8 goes into negative 120, negative 15 times. If I combine 8 and negative 15, I end up with negative 7. I don't want negative 7. I want positive 7. So I'm just going to switch the location of my negative, and there are my two factors. My two factors are 15 and negative 8. So I'm going to take this 7x and I'm going to split it up into two pieces. 15x and minus 8x. I'm going to bring down my minus 60. And I'm going to bring down my 2x, and it's equal to 0. I'm going to group my first two pieces together and my second two pieces together. I don't know, it's 2x squared. I don't know a number that goes into 2 and 15 besides 1, because there isn't a whole number that does that. But both of the first two pieces are divisible by x. So I take an x out, and I'm left with 2x plus 15. I am almost golden, because I know that I want my second set of parentheses to also say 2x plus 15. What do I have to divide negative 8 by to get positive 2? Negative 4. So my two factors of this equation are x minus 4, because that's what's outside of the parentheses, and 2x plus 15. Now I'm ready to solve for x. So I'm going to set 0 equal to x minus 4, and I'm also going to set it equal to 2x plus 15. I draw my dividing line. This first piece is a one-step equation. I add 4 to both sides, and I get x equals 4. So there's solution number 1. For solution number 2, I've got to subtract 15 and then divide by 2. Now, because I'm working with a real-world problem, it would be beneficial to actually do that division, and we end up with negative 7.5 equals x. Okay? Oh man, I've done all of that work and I've forgotten what my problem is about. So I go back up to the top, I reread it. What am I trying to do here? You want to make a vegetable garden, you have enough space in your yard to fit a rectangle with an area of 45 square yards. What are the dimensions of your garden? So I need to take those x values and plug them in to each of my dimensions. Remember that the x values we just found are 4 and negative 7.5. Negative 7.5 seems kind of weird, so I'm going to start with that. And I'm going to plug it into the easy one first. So I've got x plus 5 is my length. And if I plug negative 7.5 in, I end up with negative 2.5. Can we have a length that's negative 2.5? Heck no, we can't. So that negative 7.5 doesn't work for our word problem. And usually when we solve real world quadratic problems, only one of our answers is going to work. So x equals negative 7.5 is not the solution. X equals 4 is. But we're not done because we still haven't found those dimensions. So x plus 5 is equal to 4 plus 5, which is 9. So my length is 9 yards, because that's what the units of the problem are. All right, so I found my length. One more to go, because I still need the width. Let's clear that out. Okay, my width expression is 2x minus 3. So I'm going to replace that x with 4. Two times 4 is 8. 8 minus 3 is 5. So my length is 9 yards. My width is 5. Remember, when you're solving real-world problems, you need to write your solutions as sentences. Whew! That was a long problem. And they are long. But they aren't too difficult. Stick it out. All right, we're going to do one or two more examples. In this example, man, do I have a lot of words. Physics students are measuring the heights and times of divers jumping off diving boards. The function that models a diver's height in meters above the water is given below. V is the diver's initial upward velocity. H sub 0 is the diver's height above the water in meters. And T is the time in seconds. Okay, so keys. This is the height. It said V is velocity. It said H sub 0 is the starting height. And T is time in seconds. Okay. It says a diver who is 3 meters above the water jumps off a diving board with an initial upward velocity of 14 meters per second. Okay, so I write my formula. It said the initial velocity was 14 feet per second, so I'm going to replace V with 14. And it said that the diver's height is 3 meters. So I replace H sub 0 with 3. And now I'm looking for how many seconds it will take for the diver to hit the water. So I'm going to make a quick picture over here. Here's water. Here's a diving board, and here's my diver. The diver is 3 feet above the water. I'm looking for how long it will take for the diver to hit the water. So imagine this for a second. A diver jumps up off the diving board and then lands in the water. The water is your x-axis. This is the spot that I'm looking for. Okay? If I were to extend this parabola, is he going to dive off the diving board and then land back underneath the board? No. So whatever answer I get right here isn't going to make any sense. All right. So I look at my quadratic. I don't have any greatest common factors. So I'm just going to find two numbers that multiply to make A times C. So that's negative 5 times 3. And then they also have to add to make positive 14. Your two numbers are 15 and 1. But which one's going to be negative? If I do negative 15 and positive 1, that's going to give me negative 14. And I don't want negative 14. So I do 15 plus negative 1, and that'll give me the positive 14 that I want. So I'm going to take this 14 and I'm going to split it up into 15x minus 1x. Oh, wait. Am I supposed to be using x? No, no, no. I've got to use t, because that's what the problem gave me. So I've got 15t minus 1t. I bring down my positive 3, and I bring down my plus sign and my negative 5t squared. Now, this is kind of important. When you've got a negative in front, you're going to want to take it out. Okay? I'm going to put parentheses around the first two and parentheses around the second two. I know that because 5 and 15 both end in a 5, that I can divide both of them by 5. So I'm going to divide by negative 5, and they both have t's in them, so I'm also going to take out a t. Okay? Let me give myself a little bit of white space in here. Okay. Well, I definitely got my white space. All right, so now I'm ready to divide by negative 5t. I take that out. I'm left with a positive t. That plus sign becomes a minus sign, and 15 divided by 5 is 3. So I know that this right side also needs to say t minus 3. So I take out a negative 1. So my factors are negative 5t minus 1 and t minus 3. Because I'm looking for when the diver hits the ground, or hits the water, when he hits the water, he's only 0 feet above the water. So we are good to go for solving. I'm going to start with the more complicated one. If I add 1, then negative 5t is positive 1. And when I divide by negative 5, I end up with a negative number. We are not time travelers. We don't actually know how to travel back in time. That solution doesn't work. Which leaves me with t minus 3 equals 0. I add 3 to both sides, and I end up with t equals 3. So how long does it take for the diver to hit the ground? It takes 3 seconds for the diver to hit the ground. Remember, real world problem always ends up with real world answers. Complete sentences that relates back to the context of your problem. Okay, I'm going to refresh my screen so that I get back to my original problem. We answered this first question, and it takes 3 seconds. And then the second one says, suppose a diver who is 10 meters above the water jumps off a diving board with an initial upward velocity of 5 meters per second. How many seconds will it take for the diver to hit the water? So, essentially, you've got to do the same problem again, except now our diver is higher off the ground, but doesn't jump nearly as high with nearly as much force as the first diver did. Again, he's not going to travel back in time. So whatever we end up with that's going to be the negative answer is not going to work for our problem. Okay? I set up my function again. Negative 5t squared plus 10t Oh, wait, Miss Fitz, you did something wrong. His initial velocity, so you've got to be careful. Velocity is 5 meters. So it should be plus 5t. And he starts 10 meters above the ground. So I want you to take a minute, pause this video, and see if you can figure out how long it will take for the diver to hit the water. Did you do it? If you paid attention to your problem, you would have noticed that negative 5, 5, and 10 are all divisible by 5, and you could take out a greatest common factor of negative 5. That leaves me with an easier trinomial, one of the ones from part 1 of our video where we don't have to do factoring by grouping. We can just find two numbers that multiply to make negative 2 and add to make negative 1. Once you've found those numbers, use the idea of graphing in intercept form. Remember that the intercepts are the opposite of the numbers that you see on the inside. So here I would get a t-value of positive 2, and here I would get negative 1. He's not going to make it in the ground in negative 1 seconds. So how many seconds will it take for the diver to hit the water? 2 seconds. You should write a complete sentence. The last part says if an object is dropped, its initial velocity is 0. How would this affect the function that models the object's height? Well, so instead of the diver jumping up and then going down, this diver is now just going to go down. What do you think that's going to do? Is he going to make it there quicker or slower? So let's find out. We're going to replace h of t with 0. And then I've got negative 5t squared plus 0t plus 10. So this middle term disappears. 0 equals negative 5t squared plus 10. Hey, I only have a term with one term with t in it. I don't need to factor this at all. But we are in the factoring lesson. So I'm going to divide out a negative 5. It's going to leave me with t squared minus 2. Uh-oh. 2's not a perfect square. But what this ends up doing is giving us a fraction of a second. RT is going to be a lot smaller than it was before. We'll come back to solving this kind of problem in our next video. For now, why don't you give a word problem a try? Just as before, this is your turn. Make sure that you have it checked before you move on to the next set.